So now let's look at our first hypothesis test for a proportion. The current treatment for a type of cancer produces remission 20% of the time. An investigator wishes to prove that a new method is better. Suppose alpha is 0.05 and 26 of 100 patients go into remission using the new method. Perform a hypothesis test to see if the new method is better. Okay, so first things first. Let's state our alternative hypothesis and our null hypothesis. So I'm going to state that alternative first, and the alternative. Now, how do I know that this is a proportion? Well, it's this 20%. Remember, 20%, a percentage is just a proportion multiplied times 100. So we see that percent, you should be thinking proportion. Likewise, as I do this, I want my symbol not to be mu anymore because it's not the mean, it's a proportion. So we're dealing with P as our symbol. Now, an investigator wishes to prove that a new method is better. So he wants better than 20% remission. He wants remission that is higher than 20%. So we want the proportion to be greater than 20%, but as a proportion, that's going to be 0.20. Our null is exactly the same thing, but with an equal sign. So P equals 0.20. All right, so with that in mind, let's use this new test statistic that we have for proportions, and let's find our test statistic. Now, before we need to find P hat. You may notice that we don't have P hat. So P hat is in the information in the question. We have that 26 out of 100 patients go into remission using the new method. So 26 over 100, or 0.26. Now that's our P hat. Let's go ahead and plug into our test statistic. We will have 0.26 minus the P that's in our null, 0.20. And then on the bottom, square root of 0.20. 1 minus 0.20. And our sample size was the 100 patients. So let's work this out. On top, we'll have 0.06. On the bottom, I need to first go ahead and subtract my 1 minus 0.20 is 0.8. And I will have 0.06, and I'm going to go ahead and put all of this into the calculator. That's 0.04. And I get 1.5. Now let's notice that our alternate is greater than. Since it's greater than, when we look this up on our standard normal chart, whatever we get, we need to subtract from 1. So let's look up 1.5 on that standard normal chart. So if we look up 1.5, we get 0.9332. All right, so let's go back, 0.9332. Subtract it from 1, and that's going to be our p-value. And that's 0.0668. Okay, now we compare this to alpha. It's a little bit bigger than alpha. It's not smaller than alpha. So we cannot reject our null hypothesis. So we fail to reject. Remember, it has to be smaller than alpha to reject. So we fail to reject the null. So since we failed to reject the null, What does that mean for us? It means there is not significant evidence to reject the null hypothesis. It means that the new treatment does not seem to have a better remission than the current treatment. The new treatment does not appear to have a better remission rate than the current treatment.